Use the slope and y-intercept method to sketch the following graph. 3x minus 2y equals negative 6. Now, let's pay attention to what they're asking for. When the problem asks for using the slope and y-intercept method, I'm assuming we have to look at the slope and y-intercept form. So let's look at that. Y equals mx plus b. And if I'm comparing the slope and y-intercept form to the form that the original problem is in, they're not quite the same. In fact, this form right here is called standard form. And standard form generally looks like when you have the variables on one side and the constant on the other. So in order to actually sketch the following graph using the slope and y-intercept method, the first thing I'm going to have to do is change standard form into slope-intercept form. And in order to do that, we will have to solve our standard form for y. So I'm going to write that one more time. 3x minus 2y equals negative 6. And if we solve this equation for y, that would involve us subtracting 3x from both sides. And whenever I subtract the 3x from both sides, I will want to keep in mind that writing the x term first and the constant second is very helpful when trying to get the format of y equals mx plus b. So we're almost done solving for y. We will just have to divide both sides by negative 2. And another trick to do this is if we divide all of the terms by negative 2, we'll get our slope-intercept form a little bit faster. So the left side will be left with y. And when I'm looking at negative 3 divided by negative 2, I really don't deal with the math part of the numbers, but I do worry about reducing and trying to simplify the negative signs if possible. So negative divided by negative is positive, so we should be getting 3/2 x. And negative 6 divided by negative 2, that's positive 3. So my slope-intercept form of this particular equation is y equals 3/2 x plus 3. So now that we have our slope-intercept form, y equals 3/2 x plus 3, the next thing to do is name your slope. And remember, the slope is always the coefficient of the x. So our slope is 3/2. And the way the movement would go, if our slope is 3/2, that would indicate we go up 3 units and right 2 units. Also keeping in mind that this is a positive slope, another way to look at it if you were interested, you could also look at it as a positive slope would be negative divided by negative, and that's another way to say down 3 and left 2. So we'll get back to that once we plot the y-intercept. So speaking of y-intercept, if I'm looking at my equation, I know that's the constant after I have solved the equation for y. So my y-intercept is positive 3. So now, once we know our y-intercept and we know our slope, we can actually start plotting the points on the axes. So we always begin at our y-intercept, which is 3. So I'm going to start by plotting a point at 3 on the y-intercept part. And I'm going to use my slope. I'll use the original slope I see in blue to go up 3 and right 2 to get the next point on the line. So up 3 and right 2 would give me the next point on the line. I can continue this. Let's draw the slope triangle to make that clearer. We went up 3 and right 2. And from that point we just plotted, we can continue this again by going up 3 and right 2 as well. Get that next point on the line, and you could actually show the slope triangle if you need to. Helps you see it, helps me see it, so might as well. And we do have enough points to actually get an accurate line, but I don't have a straight edge today, so sometimes it's helpful by going backwards to find some points that might be located on the left side. So if I'm looking at my green slope, I notice that they are technically the same, but we could actually go backwards. So starting from the y-intercept, we can go down 3 and left 2. So I can actually plot my point as well. So let's do that. And notice you could also draw the slope triangle to make it clearer. You went down 3 and left 2. And we can continue this further. Down 3 from the point we just drew and left 2. And we can keep doing that if we want to make our graph consistently straight, if we don't have a straight edge. So down 3, left 2 again. And as you can see, the slope is consistent from point to point. Drawing the slope triangle, you can actually see this happening. They kind of look like stairs. And so when we look at the potential line we're going to draw, we see all these points. And if we connect all of these points, we will actually have our line. And notice I always draw my line to the edge of the axes. So while you have used the slope-intercept form, y equals 3/2 x plus 3, that's an equivalent form of graphing the standard form 3x minus 2y equals -6. So that's the equation that you've actually graphed as well.